which is our completed graph for part A. Now let's look at part B. This one we have x is greater than 3. The related equation is x equals 3. Which we already know there we go. Okay, we already know that x equals 3 will be a vertical line at x equals 3. And because the original inequality is strictly greater than, we used a dashed line. For step 2, we want to try a test point. And in this one, the point 0, 0 does work. We plug in 0 for x. We have 0 is greater than 3, which we know to be false, meaning we shade in everything on the other side of our line. And there is our final solution. If you have any questions on those, go back and review them or reference your textbook, another great resource. Otherwise, try these homework questions in your notebook. X minus 3y less than 6, and 3x minus 7y greater than or equal to 7 times the quantity 1 minus y plus 2. Once you've done those, or if you'd like to save them for later, just make sure that you do them before class. We're going to go on to part 2, where we look at two inequalities at once. In this first example, we're going to look at inequalities that are joined by the word and. We have 5x minus 2y less than 10 and y less than or equal to x. We solve both inequalities as normal. Let's start by focusing on 5x minus 2y less than 10. I still think it's easier to work with this in slope-intercept form. We find that this equation has a y-intercept at 0, negative 5. And a positive slope of 5 halves. So we will also have a solution at 2, 0. And because it's strictly less than, we use a dotted line. Let's extend this up just a bit further. Then we want to test the solution. We can test the point 0, 0. We find that we get 0 minus 0 is less than 10, 0 is less than 10, which works. So we shade in everything on the 0, 0 side of the line. Now let's look at y is less than or equal to x. We get y equals x, and this is a straight line. And we can test the point, not 0, 0, but let's test 2, 0. And we end up with 0 is less than or equal to 2, which is correct. So the blue line is shaded on this side. The correct solution will be